Hello there. Welcome to part 3 of trigonometry. Previously, you recall that we had said that trigonometry deals with measurements in a triangle. Specifically, we talked about the relationship between the length of the sides in a right triangle, and we used Pythagoras theorem. Now we are going to complement that by talking about the relationship between the sides and the angles in a right triangle. We will do that by using the famous SOHCAHTOA. I don't know if you've heard of it before, but we're definitely going to use it here. But we'll proceed as follows. In our right triangle in the picture, we are going to label the right triangle. You can see that the side Y is directly opposite to the angle theta, so therefore we will say side Y is the opposite side. The side X is adjacent to angle theta, so therefore we will say that side X is the adjacent side. And the longest side in any right triangle is always the hypotenuse, so we'll say that the side R is the hypotenuse in the triangle. From what we discussed previously, the sine of theta we defined in terms of the coordinates of a point on the terminal arm of an angle. But with respect to this triangle, we are going to just consolidate that knowledge and just say that the sine of theta is the opposite side to the angle theta divided by the hypotenuse in the right triangle. So sine is opposite divided by hypotenuse. That is SOH, opposite divided by hypotenuse. Similarly, cosine of theta is the adjacent side in the triangle, which is side X divided by the hypotenuse in the triangle. Cosine is adjacent divided by hypotenuse. And thirdly, the tangent of the angle theta is the opposite side Y divided by the adjacent side X. We will call that TOA, T-O-A. Tangent is opposite divided by the adjacent side. So this is how we're going to solve or relate the sides in a right triangle to its angles. And of course, we already know it by Pythagoras, so if we need to find any of the sides in a right triangle, we can just use Pythagoras. If we know two of the sides, we can find the third one. For example, look at this triangle here. It's a right triangle. The hypotenuse is 5, and the two opposite sides are known, 3 and 4 respectively. The angle theta is unknown. We know that there's one of the angles there, it's 90 degrees because it's a right triangle. Let's see if we can figure out angle theta. If we use SOHCAHTOA, let's start with sine. The sine of theta is the opposite side divided by the hypotenuse, which is 4, which is the opposite side to theta, and we're dividing that by 5, which is the hypotenuse. How do we find theta? Well, we know that the sine of theta is 4 over 5. Theta will be the undoing of sine. So we have to undo what sine has done to theta. Undoing what sine has done to theta will give us theta. And this undoing is called the arc sine. And it is written as shown. Sine, and then you have it's kind of like an exponent of -1. It's not an exponent. It's just called arc sine, everything together. So to find theta, we will just take the arc sine of 4 over 5. Now we have to use a calculator to do this. Your calculator has to be in the degree mode for you to do this. So make sure your calculator is set in the degree mode. And if you take the arc sine of 4 over 5, you will get that theta is 53.13 degrees. To find the angle alpha, the other missing angle, recall that we had said that the sum of the interior angles in any triangle is 180 degrees. That means if we add alpha to theta and we add the right angle to it, we will get 180 degrees. If we substitute what we know that theta is 53.13 degrees in the equation. We can solve for alpha. Alpha will be 36.87 degrees. That is if we use sine. But we can also use the cosine trigonometric ratio. Cosine is the adjacent side divided by the hypotenuse. So cosine of theta is 3 divided by 5. And theta, just like we did with the sine, will be the arc cosine of 3 over 5. So we have undone what cosine has done to theta to give us what theta is. If you use your calculator, you will see that theta is the exact same as we obtained previously. Theta is 53.13 degrees. We can do the same thing using the tangent trigonometric ratio in the right triangle. Tangent will be TOA, which is opposite divided by adjacent side. The opposite side to theta is 4, the adjacent side is 3, and theta will be the arctan of 4 over 3. And guess what? Theta is the same thing as we have obtained previously, 53.13 degrees. So it doesn't matter, as long as you have enough information, you can use sine or cosine or tangent to relate sides and angles in a right triangle. Let's do another example. Let's find the missing parts in this right triangle. The missing parts are, you can see the side y is missing, and you can see the angle theta and angle alpha are both missing. Now, because we don't know any angles, well, we may want to start by looking for which of these three trigonometric ratios is most appropriate here. Well, if you look at cosine, you will see that you can relate the adjacent side 4 to the hypotenuse. Both of those are known. And if we take the arc cos of the relationship there, so cosine of theta is 4 over 10, theta therefore will be the arc cos of 4 over 10. Therefore, theta will be 66.42 degrees if you use your calculator. And since we now know theta, and we also know there's a right angle, the sum of the interior angles in a right triangle, or any triangle for that matter, is 180 degrees. Therefore, the missing angle theta, we can solve the missing angle alpha, we can solve for by simply subtracting 66.42 degrees plus 90 degrees from 180 degrees. Our result there will be 23.58 degrees. Now to the sides. By Pythagoras, since we know 3 of the sides, we know the hypotenuse, and we know one of the sides as 4, we can use Pythagoras' formula as y squared plus 4 squared equals to 10 squared. That says that the square of the hypotenuse is equal to the sum of the squares of the two other sides in the triangle, and we can then solve for y by rearranging the formula, and y will be the square root of 84. When we did radicals, we learned to simplify radicals like this and write them in exact form. Well, you'll see that if you think about the factors of 84, we can write 84 as 4 times 21. And 4 is a perfect square. Therefore, recalling what we did under radicals, our result there will be 2 times the square root of 21. That will be the value of y. Now, let's solve a problem, an application problem that will use a right triangle. And here is the problem. A hiker sketches a map of her destination D from her starting point O. So she started from O and she's going to D as shown in the picture. The hiker can travel only west, then north. To the nearest kilometer, how far must she hike to get to her destination? Many times you are not given a picture to accompany your problem. But in this case, we have a picture that accompanies the problem, so that's good for us. In the picture, you can see the starting point O and the destination D. And you can see the 4 cardinal points, north, south, east, and west. And in terms of the north, south, east, and west, this lady is going to be going in the direction 140 degrees, right, from east, which is where you are going to have your 0 degrees from what we've talked about so far. So how do we deal with this problem? We want to figure out how far she must hike to get to her destination. Well, one of the first things to note is that for her to go west and north, that means that you can complete that picture. You will have a right triangle there. If you go west from her initial starting point O and you go north to get to D, you will form a right triangle. Those two sides, y and x, are unknown. And since the question is asking us the distance she must hike to get to her destination, we need to find x and y. Moreover, to complete the picture, you can see that in the right triangle, from elementary geometry, you know that the sum of the angles in a straight line is 180 degrees. And since you know 140 degrees is one side of it, you know right away that 180 degrees minus 140 degrees will give you 40 degrees to complete the picture in that right triangle. So, let's proceed now to find x and y. If we think of SOHCAHTOA, we can use any of the three or the one that's most appropriate here. But sine is very, very easy to use here because sine relates the opposite side y to the hypotenuse 10. Since we know the angle 40 degrees and we know the hypotenuse is 10, the only thing we don't know is the opposite side y. Therefore, we can write the equation sine of 40 degrees is y divided by 10. And in our calculator, if we set our calculator mode to degrees and we do sine of 40 degrees, our result is as shown, 0.6428. And we can solve that equation for y. Y will be 10 times 0.6428 and y will be 6.43 kilometers. So now we know how far north she has to go to get to her destination. But we are not done yet. We need to find how far west she has to go to get to her destination. For that, we can use Pythagoras. Because we now know two sides in the right triangle, we can use Pythagoras to find the third missing side. Y squared plus x squared equals to 10 squared. Since we already know y squared, we can substitute in the equation and solve for x by taking the square root of 10 squared minus 6.43 squared. Our result is 7.66 kilometers. Now to answer the question that was asked, which is, how far does she have to hike to get to her destination? We will simply need to add x to y. So x plus y is the distance she has to hike. And since we know x and y, we can just substitute. And if we add them together, our result will be 14 kilometers. Now you try and solve or find the missing sides in these right triangles. Like we've done previously, please pause the video now and try these examples. And when you have finished, you can continue the video and check out what I have done. So please pause the video now. So what did you do? Well, here's what I did. In the first triangle, you can see we can label the missing part. X is a side that's missing, and angle alpha is also missing. By SOHCAHTOA, if you think of SOHCAHTOA, sine of theta is the opposite side divided by the hypotenuse, 12 divided by 13, and the arcsine of 12 over 13 is 67.4 degrees. And since the sum of the interior angles in any triangle is 180 degrees, you can find alpha by simply subtracting the sum of 90 and 67.4 degrees from 180 degrees. Your result will be 22.6 degrees. And by Pythagoras, we can figure out x, the missing side. X squared plus 12 squared is 13 squared by Pythagoras. And if we solve for x, we'll find that the size of x is 5. And similarly, in the second triangle, we can label the missing side as x and the missing angle as theta, and the hypotenuse we'll just call r. Since we already know two angles in the triangle, we know that the sum equals 180 degrees. We can solve for theta. Theta will be 60 degrees. And if we think of SOHCAHTOA, we can use TOA this time. Tangent of 30 degrees is the opposite side divided by the adjacent side. And we can solve for x by dividing 4 by tangent of 30 degrees to give us 6.9. And finally, to find the missing hypotenuse, by Pythagoras, we know that the square of the hypotenuse is the sum of the square of the two missing sides in the right triangle. And if we follow through on that, we'll find that r is 7.98 degrees. It's 7.98. So this completes our video, our part 3 on trigonometry.